All right, I managed to do some work offline, figure out some of the bugs that were happening with the rotation I was doing, and I've actually figured it out, I think. So now I can use my mouse to basically control the rotation of this object, which are just 3 planes put together. And that works decently well. Oh man. Hold on, messed up shortcuts. There we go. It's a blessing and a curse having a complicated programming setup. Okay, so it ended up being a lot of math to get this done. It was pretty worth it. I'm really satisfied with how this turned out. I think what I'm gonna try doing now is I probably won't do this damping effect. I don't know if that's worth it, but this panning I think will be worth it. Being able to do that with the right click button. I might end up doing the damping if I don't know if I really want that or something. But firstly, let me see if I can find a hook in the scene to see which of the 2 keys is being dragged. I guess there's this buttons thing that's passed. So let me just print. I'm gonna try printing buttons, see if I can detect the right mouse. Oh, I overwrote it, I think. I think on mouse drag is being overwritten by this. So I'll try printing the buttons here. Okay, so this is button 1, I guess, and when I right click, I guess that's button 4. Okay. So I guess what I want to do is, actually, let me see. If I hold like shift or something and then I drag, nothing. So that's 4. The scroll wheel is 2. Interesting. What's 3? Whatever, not important. So I guess what I'm gonna do is, if the button is 1, hopefully this doesn't change between operating systems. So maybe I can just say if buttons equals 1. And this is the, I'll just comment this as the left click. That's when I want to do all of this, and I just crashed it. Because I saved when it wasn't indented. So this should do the same thing, the exact same thing. And it does. Now if I check for the button to be 2, that's when I'm going to try to pan it. I'll just print insert panning here. So rotation, that's fine. Panning. And it's actually not happening. Oh, did I put it was 4, right? New, what's going on? I'm doing good. I had a bit of a slightest headache earlier, so that wasn't that great. But I think I'm getting over it now. Okay, so now it knows that it's supposed to be panning even though it's not doing it. So that's great. I think what I'm also going to do is I managed to find a way that I can bound the polar angle that the camera is from the z-axis. And I think the easiest way to show this is just to change it so that the camera is from from the z-axis. And I think the easiest way to show this is just to change it. So here the polar angle is bound between 0 and pi over 2. And now when I'm rotating this, I can't go beneath this plane, because that polar angle, that angle off the z-axis, is bound at pi over 2. I also can't go upside down, because if I unbounded this, it is actually possible for the camera to go over the z-axis in this other direction, and then that would reverse all the controls. But the way it is now with this bound is more similar to the way this is set up. Can I ask a random question? Yeah, sure. But this is set up so you can't go underneath the ground, and you can't go upside down like that. Which is great. So what I'm going to need to do now is figure out the panning directions. So here, this is where it's panning. And it's using negative D point, I guess? So yeah, I guess that's the direction I'll use. The question is, how do I convert that to a vector that I can actually use? So I can see from this that the direction you pan, it's always it's in a direction parallel to the ground, basically. So how would that work mathematically is the question. If your polar angle is 0, then it's really straightforward. Here, or when you're somewhere in between, that's a little less clear. If you dev a VPN service, will you have scare of releasing it because of bad traffic? If you dev a VPN service, will you be scared of releasing it? I don't think so. VPNs are pretty mainstream now. A lot of people run them just to be a little safer. So I don't think so. Alright, I might end up having to bust out paint for this one. Because in one sense this is fairly straightforward. If this is like the back of the camera, and it's looking in this direction, which would be the negative z-axis, and this is essentially the ground, the xy plane. Something like that. If I drag in this direction, Daryl Golden, what's up? If I drag in this direction, it's pretty clear what I'm looking for is just the x-axis from the perspective, from the camera's local coordinates. And this is the negative z direction in the camera's local coordinates. But if I drag up or down, how do I map that onto the x or y axis? Because I think what I might have to do, this is the XY plane, this is the camera, this is what it's looking at. So the camera's x-axis is going into the screen. That's the positive x direction. This is the z-axis. What I want is, if that's the y-axis, the camera's y-axis, I guess I want to project the y-axis onto the xy plane. That'll give me the direction. I'm basically looking for this direction. And the only ways I can really get directions is by crossing vectors. So I guess I could cross the... And the only ways I can really get directions is by crossing vectors. So I guess I could cross the... Maybe all I have to do is cross the z-axis with the camera's x-axis. Would that make sense? It would in this picture, since if I do the right-hand rule, z crossed with x would be going in this direction. I think that even works if the camera is up here. The camera's x-axis is still going into the screen like this. So I think that is right. Let me try doing the sideways direction first, before I do the up and down. So let me try to figure out the horizontal shift. And I'll just take D point at, I think 0 is what I want. It might be negative or something. It probably is a negative, actually. And how will I do that? So this is just going to be end up being translating by this distance in the x direction. So if I'm lucky, let me open up the OpenGL utils. This. If I'm lucky, that'll just be this self.camera.model. I can actually already think of how this isn't going to work. And because of this math is wrong. This is going to be translation matrix. That's going to be it is in the x direction. That's going to be something. Then I'm going to multiply that by the model matrix again. And is that just this vector? Is it? Could it be? This is the scalar. Then I'm going to want this times the camera's x-axis. So I'll need... I actually found something like this before. This is the camera's y-axis. Where I just took basically the second column. And the x-axis will be this with 0. Whoops. Okay, then let me multiply that. I basically do this horizontal shift times... Actually, I don't know if you can unpack like that. So let me say shift vector or something like that. This times the camera x-axis. And this is what I'll put in here, or I'll have to unpack it. So something like this. All right, let's see if that lets me move laterally. So this is working the same. Translation matrix not defined, that's actually right. This should be appended with OpenGL. Okay, let me retry that. Okay, that is working. Up and down, not doing anything. Now, what I'm pretty sure will happen is that if I move this to the side like this, and then move up and down, yeah, then weird stuff starts happening. Because it's rotating around the origin, when it should be rotating around like this shifted point. But if I restrict to just going side to side, I think that's working. So that works for the horizontal part. As for the vertical part, I think what I was doing before is valid. I think Z cross X is pretty much what I need here. I think what I was doing before is valid. I think Z cross X is pretty much what I need here. Where X is the camera's x-axis. Let me just look at that again. Yeah, I think it's fine. So let me try doing that. So this will be the vertical shift. Whoops, what'd I do? This will be the vertical shift. I'll take this at 1. Get the camera's x-axis, where I already have that. I'm going to take the vertical shift. Not times this. I'm going to want to do the cross of the z-axis, which is out. It's not up. Then cross out with this. No, with the camera's x-axis, sorry. And multiply that by the shift. So this is going to translate that. I guess I can just add these two. I'm going to try doing it separately. Actually, at first, what I'm going to do is comment this out. Just make sure I'm doing this one right. And do just this. So this is Z cross X. And I think this should at least do what my calculation is doing. So I get an error, camera x-axis. Let's try doing that again. It looks right. It's not doing anything crazy, which is good. Okay. So now I'm going to try to do both of these. So I'll get a horizontal shift. Is this. Vertical shift is that. This will be the horizontal shift vector. Okay, this will be the vertical shift. This will be the vertical shift vector. Put the vertical there. Okay. Looks right. When I combine it with the rotation, that still does weird stuff, but that's expected. But I do need to fix the way it interacts with the rotation. If I stick to rotation, that seems to be fine. Actually, let me see if I get like this. So I'm currently on the flat plane of the ground. I'm not sure if that's doing what it's supposed to. Actually, it looks like it's not. Because if I get in the plane of the ground here and then I do it, it zooms. The effect is that it zooms, and I don't think it's doing that. From this angle, it's doing the same thing, I think. If I got, well now. So starting out, it's looking straight down, and this seems to be working perfectly. When I go to here, I think that's still right. I'm not sure if it's moving just straight up and down or along the plane of the x-axis. It's hard to tell. But maybe it's not actually. across the z-axis and the camera's out-axis. And the camera's x-axis, I mean. Is that consistent with, where's that? Still seems right. Still seems right. Even if the camera was down here, the camera's axis would still be into the screen. And crossing z cross x would still give me this. I'll have to test that, but first, before I do that, when I do either one of these shifts, I'm gonna have to basically store a target point, and then I won't want to use any calculations relative to the origin. I want to have a target point and then translate that as I translate the camera. So it should never affect anything relating to the z-axis. Yeah, even if I translate what the camera's looking at, the direction in the z-axis will still be the same. What will change actually? Will be the angle. Oh, around the z-axis. This will change because it won't be around the z-axis anymore. It'll be around the translated point. Is that the only thing? No, this actually will change too because I won't want to translate. I won't want to rotate around the origin when I increase the polar angle. So I should start with this, I think. How can I rotate it? If normally... I'll just duplicate this. If normally this is happening around the origin, and this is where the polar angle is coming from. And this would be theta. If I were to shift that target, say to here, how do I rotate around or rotate relative to this point? I shouldn't have placed it there, but say here. Then how do I get the angle relative to this point instead? Well, I have to... I think it shouldn't be any harder than getting a point. This is the point that I want to rotate around. What I'll need is a vector to rotate around. A vector and then the angle. So the normal vector and the angle. So the normal vector, basically the one coming out of the screen, will probably be, if this is the target and this is the camera, and I want to get out of the screen, then I'll have to cross the camera's displacement from the target and cross that with, I guess, just the z-axis. And that should give me basically the normal vector around which to rotate. Okay. So let me try doing that. I'll just comment this. Get the vector to rotate around. And for that, I'm going to do... the camera's position is already right here. I'll just bring this up. Get numpy.cross camera position with the z-axis. Okay, this is the vector I want to rotate around. So I won't just use rotation around the z-axis. Is this right? Wait, this is for the polar angle. Is this right? Wait, this is for the polar angle. The rotation off the z-axis. So that's not what I'm trying to do right now. I need to get basically a vector from the target point and going upward. Which shouldn't be too hard. It should just be... No, wouldn't this still be the z-axis? How can I rotate about... If this was the target point, and this was another point, where this was the target plus just the z vector, then this vector would still be z. It seems like the calculation I'm doing would always rotate around the z-axis, which isn't what I want to do. I want to rotate around a different axis. Let me see what the space ops functions do. I think what all of these do is rotate in place. So I could rotate the camera in place, but not around a specific vector. Yeah, rotation about z. I guess it would be possible to rotate it in place, to translate it to the target, rotate it in place, and then translate it back. But that won't fix its position. Hold on, I'm gonna back up on this. And see what I already have. I already have the orbiting. And you can pan, but only if you stop orbiting after you pan. I feel like rotating around... Okay, I'm gonna have to diagram this out again. How can I rotate around an arbitrary axis? So if this is the z-axis, I can rotate around this axis just by multiplying by a rotation matrix, and that's all. If this is the origin. But if I want to rotate around an axis over here, how do you do that? This is just some arbitrary v. Maybe what I'd have to do, I'll know this point, the target. I think what I'll have to do is whatever the object is, this will be p, this will be some p prime. I have to translate it by the displacement vector to the origin from the target. So I'll have to take the point that I'm trying to rotate around this axis. I don't know, this can be p, like, I guess this one's double prime, so this will be triple prime. Translate to here, rotate around the z-axis, and then translate back. And that should do it. Yes? To rotate around an arbitrary axis. So then step 1, I'm gonna have to always keep track of this target thing, which I don't think is super hard. I think all I need to do is have it somewhere like here. So initially, camera target, it's gonna be the origin. And each time I pan, I'm gonna want to add these vectors, the vectors that I panned by, to the camera target.